In part 1, we saw how to add vectors. Uh, Regarding addition of vectors, we have some rules. That vector addition is a commutative property, that is, a plus b will be equal to b plus a. So the order is not important, whether you add a into b and then you add b into a. It will give the same result. Okay. Now we'll talk about something about unit vector. As the name suggests, it's a vector of size 1. The mod of unit vector is 1. If there is a vector A and suppose its mod is 6, and if you divide equally this vector into 6 equal parts, 1, 2, 3, 4, 5 and 6, then one part will have a magnitude equal to 1. So this one part is a unit vector, and it is unit vector in the direction of A. So we can write A cap. Cap indicates unit vector. So A cap is a unit vector in the direction of A vector. And how we found this A vector? By dividing this A vector by its modulus. So the general formula becomes A cap is A vector divided by its modulus. So what's the use of unit vectors? Suppose we have a vector A and its size is mod A. And suppose we have to write another vector which is b, suppose, but the modulus of b is different from that of a, and b is parallel to a. So we need a vector b which is parallel to a in the same direction, but its modulus is different. So how to find b? Suppose the vector b is having a modulus mod b. So b vector can be written mod b into a direction, into a unit vector, like this. So this is how b vector can be written. And since b and a, these two are parallel, their unit vectors are same, because unit vectors have magnitude 1 and directions are same. Therefore, unit vector along b is same as unit vector along a. So this is why we need unit vector, because if a vector is given and we need to write another vector which is parallel to it, then we can take help of that given vector. Similarly, if a vector is given, suppose a, and we need to write another vector which is anti-parallel to it, c is anti-parallel to a. So how c will be written? C will be written as mod of c into c cap, but c cap is minus of a cap because its direction is just opposite to a. So this is how an anti-parallel vector will be written, like this. So this is a use of unit vector. We can write with the help of unit vector any vector which is in that direction. Okay, some ready-made unit vectors are there. So in the direction of x, we have a unit vector, we denote it by I cap. So I cap is a unit vector in the direction x. Similarly, we have a unit vector j cap. It's denoted by j cap if it is in y direction. And similarly, if a unit vector is in z direction, then it's denoted by k cap. So these are the three unit vectors uh, widely used, I, j and k. Now, with the help of these unit vectors, we can write any vector. So let's see how. Suppose we take a vector in xy plane first. Suppose this is a vector a in xy plane. So first I'm taking xy plane, and suppose it's making theta x and theta y angles with these axes respectively. Suppose A vector is written as B plus C, where B and C are two vectors in x and y directions respectively. So in figure we'll write like this, we'll show B and C as this. So B is a vector in direction x and C is a vector in y direction, and these two vectors are such that when these two are added they give A. So it's like this, B and C. So B and C are components of A. If some vectors when added give another vector, then those vectors which are being added, they are called components of the vector which is the resultant of addition. So these two B and C are components of A, and since B and C are in x and y directions, they are perpendicular components, so they are termed as rectangular components. Rectangular components. So rectangular components means perpendicular components. Okay. So how to write B vector? Mod of B into B cap. And what is B cap? B cap is a unit vector in the direction x, and that is I cap. Similarly, C vector can be written as mod of C into J cap, like this. And what is mod of B? Mod of B is mod of A cos theta x. What is mod of C? Mod of C is mod of A cos theta y. Theta y will be formed here. So cos theta x is base over hypotenuse. For this angle theta x, base is the mod of B vector, while hypotenuse is mod of A. So therefore mod of B will be equal to mod of A cos theta x. And similarly for theta y, for this angle, C becomes base. So cos of theta y is base. Now base is C, mod of C over mod of A, and therefore mod of C can be written as mod of A cos theta y. If we had used theta x to write mod C, then for theta x, the side C is perpendicular, and then it would come in the form of sine theta x. Okay, so these are the results, and therefore A vector can be written as mod A cos theta x I cap plus mod A cos theta y j cap. And using Pythagoras theorem, we can write mod of A square is equal to uh, summation of squares of mod B and mod C, where mod B is mod A cos theta x and mod C is mod A cos theta y. And if you cancel out mod A from both sides, so then we are left with this expression. So if these two cancel out, so 1 is equal to cos square theta x plus cos square theta y. Okay, similarly, if we have a vector in 3 dimensions in space, then that vector will be written in 3 components. Suppose this is x direction, y direction, z direction, and a vector is somewhat like this, A. Then this vector can be found by adding again 3 vectors like this. Okay. So now here we have a vector A which is equal to B plus C plus D. Now B, C and D are components of A, again rectangular components, and now we have 3 components. Okay, mod B can be written as mod A cos theta x, where theta x is the angle between A and x axis. This is angle is theta x. This angle is theta x. Similarly, mod c can be written as mod a cos theta y, which is cos theta y, where theta y is the angle between a vector and y axis. So this angle, this is theta y. And similarly, mod d can be written as mod a cos theta z, where z axis makes theta z angle with a vector, like this. Again, mod a can be written as, or again, a vector can be written as mod a taken common cos theta x I cap, cos theta y j cap, and cos theta z k cap, like this. And we have x direction, we have y direction, and we have z direction. So this is b vector, that is mod a cos theta x. Parallel to y is a c vector, which was mod a cos theta y. Now, using Pythagoras theorem, we can find the size of this side, which is not a vector. This is just a side in xy plane. So this side using Pythagoras theorem will come out mod a square cos square theta x plus cos square theta y under root. Suppose the side is simply d for convenience. We are left with a side mod a cos theta z and a side which is mod of a vector. So this was originally a vector and its size is mod a. So again using Pythagoras theorem, in this triangle, and this triangle is in fact 90-degree here. It's a three-dimensional situation. So using Pythagoras theorem again, we can write mod a square is equal to d square, that is this side, plus mod a cos theta z square. And just putting the value of d and solving, we'll get this mod a square bracket cos square theta x plus cos square theta y plus cos square theta z. And cancelling out mod a square, will get this expression. This cos theta x, cos theta y, and cos theta z, these are called direction cosines. Direction cosines. Okay. So a vector in space can be written in the terms of these three components, I, j, and k. Suppose a vector is like this, 2i plus 4j plus 3k. It means if you start from origin, and you move 2i along 2i vector, you reach here. Then you move along 4j vector, you reach here. 4j vector is parallel to y-axis. And then if you move along 3k vector, so which is a vector along z direction, then from origin you reach to this point. And if these 2 points are directly connected using a vector, then this vector is the addition of these 3 vectors, and which is a. So here a vector is like this, and these are the components. So how to write mod a? Mod a is under root the coefficient of I square plus the coefficient of j square plus the coefficient of k square. So this is how mod A is written.